So video demonstration number 4, I believe. And again, it's going to be about exothermic reaction. It was directed to students there in 6th grade. They're experimenting with some chemical reactions in the lab. Some of them like them, some of them don't. So I was invited to this school to do a presentation to the students that you can also have some fun while we do chemistry reactions. So here you go. Good morning, students. My name is Professor Carlos Hernandez. Actually, I teach chemistry in South St. Paul Middle School, actually to 6th graders. And some of my students are just like you. Some of them like to go to the lab and play with some reactions, some of them don't. So I'm here to teach or to show you what we did in the other school. So every single one now of them like to do chemistry reactions. So I'm gonna try to teach you, show you some exothermic reaction. Exothermic reaction is a fancy word for a fancy word that we have in the science world for to take heat from the from the environment, to the environment. To the environment, to the outside. Now, because X means out, and thermic means heat. So we're taking heat to the outside. So like a really this is a really good example that we're gonna demonstrate here today. But before that, let's talk about a little bit about like what about exothermic reaction means. So all examples actually of it. Let's a good example of exothermic reactions now. Like we're in the fall time. This season is the fall. It's kind of cold outside. Most of you friends or your parents, friends that come over, and they have a bonfire. So that you throw the log in there, they start it on fire, and fire comes out, and that creates heat around. And we, as a person that is sitting around doing marshmallows, we use that heat to keep us ourselves warm. So that's an example of an exothermic reaction. Another huge example of exothermic reaction we can say is that when we launch a spacecraft to the space, a space rocket to the space. When the spacecraft needs a huge amount of energy, to make sure that it takes off from the Earth all the way to space. And when we does that, the fuel that has contained in those tanks, there is light up and then just go. It's really fast, and they create some plumes of human gases and whatnot. They call it aluminum oxide, and that aluminum oxide does creation also the exothermic reaction. So it creates heat around, and then you see all those plumes. That's all that foam, all the smoke is full of heat. That's an exothermic reaction too. Another one is coils. They use in the old locomotives. They use gas as no gas, like as a gasoline now in the cars, but then in this time they use coils. So you have the conductor shoveling coils inside to this huge oven, which has a lot of fire and a lot of heat inside. And when the coils go in there, they kind of disappear and they create this gas, these fumes, which goes into the pipes and makes the wheels go around faster in the train. So that's another way to create exothermic reaction. Now, the other side of exothermic reaction is endothermic reaction. Endo means inside, and thermic heat. So it takes the heat to the inside. One of those examples, again, we use this season, the fall, we can use the photosynthesis, which photosynthesis actually changes, the leaves are changing. So that's what it takes. The photosynthesis takes the heat of the sun and makes the plants change color in the inside. That makes the heat and keeps them warm, and it creates photosynthesis. Another one that we can see as like when we eat food, we have energy inside, and this creates through ATP. And ATP is something that keeps ourselves going and strong during the day. you know. So that's another example, the endothermic reaction. But we're here to demonstrate about like what is exothermic reaction. So I have some ingredients that you can find at home. We have our main ingredient is hydrogen peroxide. Now we have only the 3%. If you want to like a huge reaction, you can use the 6% or the 20%. Yeah, the 6%, which will be enough. We have this here, and we have an empty bottle. Used to be a propel, bottle is gone. So we have this. We have yeast. That's going to be our catalyst. I can explain something about it pretty soon. And then we have a dish soap, and also we have some food coloring that you can find anywhere to make your cookies or your cupcakes or anything like that. So to do this experiment first, what we need to do is safety. Safety first. Always in chemistry lab, you have to use protection. So in this case, we're going to use this because we don't want any of the hydrogen peroxide getting into your eyes. So we open the bottle, and we're going to pour some hydrogen peroxide in there as much as we can. Then we want to put some dish soap as much as we can also, and some food coloring. We do that, and we mix it. We mix it until everything comes all together. And now over here, inside of this cup, we have hot water. And the hot water is going to mix with the yeast. Now the yeast is going to be our helper. Okay, why is that going to be our helper? Because it's going to be our catalyst. And what it's going to do is going to take the extra oxygen the formula of the hydrogen peroxide has an extra molecule of oxygen, H2O2. So we want that 2 out of there. The O2, so it just stays H2O. So we're going to do that. So we mix, we stir it up so no crumbles are in there, and we're going to pour this carefully, and you're going to see our elephant toothpaste, also called. So we pour this in here, and you will see the reaction, and there you go. Ta-da! There's a lot of foam comes out, you know, and then you can feel the bottle, and it's hot. That's an exothermic reaction demonstration that we have today. So sometimes works, sometimes doesn't. Just make sure that you have always an adult with you, especially when you are working with hydrogen peroxide. It can irritate your eyes if it gets in there, so just be careful. And I hope you enjoy. So I hope this change your mind, and you can go to the lab next time happy, and you just think that you're going to make something fun and that you're going to do something great about it. So I hope you like it. Thank you.